Okay, I'll jump right in. So welcome everyone. As Marianne Piet shared earlier today, the next I'll present new strategies for sustainability and resilient cooling. The first speaker in this series is Dr. Ronen Levinson, a staff scientist and leader of the Heat Island Group at Lawrence Berkeley National Lab. Ronen and his group developed cool roof, wall, and pavement materials, improved methods for the measurement of solar reflectance, and quantify the energy and environmental benefits of cool surfaces. I will monitor the Q&A and chat functions for audience questions, and we'll keep the last few minutes for Ronen to answer them. So with that, I'll hand it right off to you.
Thank you, Laura. Good morning, everyone. Today I'll speak about cool retrofits for homes, top strategies to save energy, improve comfort, and boost resilience to extreme heat. Extreme heat. As many of you may know now, heat now causes more deaths than hurricanes, tornadoes, or floods in most years. And it's killing a lot of people. In California, we have a particularly nasty problem. We don't have just extreme heat. We have blackouts that go with them when the utility will turn off the power to avoid wildfires. So you may not have air conditioning even though you have the equipment. Another issue is that the heat is just getting worse. If we look in California's Central Valley, for example, in Fresno, by mid-century, we're expecting 22 extreme heat days. These are days where the temperature exceeds 106 degrees Fahrenheit, so 3 weeks. And it's going to be more like 8 weeks of extreme heat by the end of the century. It's bad now, and it's only going to get worse. So what can we do about this? There are a number of international and domestic projects. I'm going to talk about a few of them. One is called IEA Annex 80, that's International Energy Agency. Annex just means project, resilient cooling of buildings. And it seeks to make resilient, low energy, low carbon cooling strategies common and preferred solutions in buildings. So why do we want to do that? First, we want to make the building occupants more resilient to hot weather. This makes them more comfortable, healthier, and productive. We want to make the building cooling systems more resilient to hot weather, improving their ability to meet the cooling load. In other words, we may have cooling systems that aren't designed for today's hot weather. And we also want to make the power grid more resilient to hot weather, reducing failures, which means blackouts and brownouts. The annex is looking at 14 cooling strategies. The first group reduces the heat gain into the building. This is things like solar control materials or heat storage and release. Another approach is to remove sensible heat from the space. And these are all of your mechanical air conditioning strategies, but also use of natural ventilation and natural heat sinks. The third category is enhancing personal comfort. And this means things like fans, whether they're ceiling fans or personal fans or other more complicated strategies. And the last is removing latent heat from the space, high performance dehumidification, things like desiccant wheels and such. We've looked at what some of these measures can do. And just as an example, the Berkeley Lab team, in collaboration with UC Berkeley, has been studying a number of passive and low energy cooling strategies, and we found that they can reduce overheating in a pre-1980 single family home in the US by up to 70%. Here we're showing the reduction in discomfort. The actual metric's a little complicated, but we want this discomfort metric to go down. And we can see that something like a cool wall could reduce your annual discomfort by about 12%. Natural ventilation can be upwards of 70% reduction. And we get some really impressive results too by using various solar control window strategies and by using ceiling fans. So there's a lot of potential for these passive or low energy measures to make our homes more comfortable. Another project is focused on California. And this is Cal Thrives, a California toolkit for heat resiliency in underserved populations. And this is sponsored by the California Strategic Growth Council with a whole bunch of partners. And this project seeks to develop recommendations that will help communities such as those in Fresno better adapt to extreme heat. The project begins and continuously uses community engagement to find out what people's needs and wants are. It models buildings individually and on the neighborhood scale. So we're looking at a whole community. We also consider what are the best ways to use cooling centers. These are places where people can go when it's very hot. And we also model not just indoor, but also outdoor measures, such as the use of cool walls or shade trees. And all of this is to generate a heat resilience toolkit, which includes lots of helpful information like fact sheets and the results of the modeling. We also have this heat vulnerability index tool, something that's online that you can go to see where the biggest problems are, plus other resources. In the Cal Thrive study, we modeled 9 passive indoor cooling measures in a worst case heat wave with and without grid power. So we show here the various 9 things, which include solar control measures, insulation, natural ventilation, and so on. We're also evaluating 8 active indoor cooling measures, things like fans and central air conditioning and mini split air conditioning and portable AC and evaporative AC and so on, along with 4 different passive outdoor measures, reflective pavements, reflective walls, shade trees, and canvas canopies, things that you can hang to provide shade. What we found in the Cal Thrives project is that in these neighborhoods in Fresno that have disadvantaged communities, window films, roof insulation, and cool walls are the most effective passive measures overall. On the top floor of the homes, though, natural ventilation is a very good strategy. And I want to focus in a little bit on one approach to cooling that we spent a lot of time examining and think it's just such an obvious thing to do that it's worth a little bit of attention, and that's cool walls. A cool exterior wall is just one that is reflecting sunlight to stay cool in the sun, and this reduces the need for air conditioning, saving energy, money, and carbon. This is a building that I walk past daily, and just to give you an idea of the variety of colors and reflectances that you might see in typical walls. So a conventional wall might reflect about 20% of sunlight, and an off-white or a dull white wall that might reflect about 60% of sunlight. And there are things that are in between, and there are things that are even brighter and more reflective. But the simplest idea of a cool wall is you're going from a conventional wall to some sort of light colored wall, and you're boosting your solar reflectance from 25% to about 60%. We evaluated by conducting over 100,000 building energy simulations, the annual energy, cost, and emission savings that you get in each of California's 16 climate zones and in 15 climates around the United States. And what we found is that cool walls save energy, CO2, and money in homes, offices, and stores in all California climates and in US climate zones 1 through 4, which means roughly the southern half of the continental United States. Cool walls are also an effective way to mitigate the urban heat island effect, which is the elevation of the air temperature in the city compared to that outside the city. What we found is that in a study done for LA, which is a common place with urban heat island problems, cool walls could lower the outside air temperature nearly as much as reflective roofs. You might ask why, because roofs are in the sun all the time and walls are only in the sun part of the time. But it comes down to walls are by definition half as high as roofs, and which brings them closer to the ground level where we care about it. Plus, there's more wall area than roof area. So cool walls are an effective strategy not only for saving energy, carbon, and money in individual homes, but also for mitigating the urban heat island effect. Another great thing is that cool wall products are sold today. This is a picture showing a whole bunch of commercially available wall products that we tested. And those towards the left are what I'll call more conventional walls, and they're tend to be darker in color and less reflective. And those towards the right are more reflective and cooler. And there are no official standards yet, but what I would say is that if you're looking for cool walls, well, you can find what I would call higher tier cool walls, those that are reflecting at least 60% of sunlight. And then there are lower tier cool walls that are reflecting 40 to 60% of the sunlight. And so that's what I'm talking about with regard to a cool wall. Another nice thing is that cool walls stay clean and reflective. Cool roofs, we know from long experience, can get pretty dirty. And so when we model cool roofs, we assume that they get dirty on day one. But our 3-year exposure of wall product specimens at the usual locations used for testing envelope materials found that the average solar reflectance loss after 3 years was very small. And that's not a surprise because walls are vertical and vertical surfaces don't collect water. If you have water ponding on your wall, we have much bigger problems to worry about because gravity has failed. Now, because cool walls are an effective urban heat island strategy, there is now a pilot credit in the LEED program that will give you a point for using a cool wall to mitigate the urban heat island effect. And there is also a cool wall product rating program to be operated by the Cool Roof Rating Council, which is to launch, I believe, later this month. So cool walls are now a thing. You can get some credit for them in LEED. There will soon be a product rating system that will help you find cool walls. And if you'd like to learn more about them, I would just follow the links that we have for news releases from the Berkeley Lab News Center. And with that, I want to thank you for your attention to my whirlwind introduction to some resilient cooling strategies.
Thank you so much, Ronen. So far, we have one question that came in, which is, what are the mold considerations for cold walls in a hot climate?
I don't think that you really consider the walls to be unusually cold in that you can already walk down the street and find any number of light colored walls. They're not exceptionally cold. Also, regardless of the color of the wall, say an east wall is going to be dark and cool in the afternoon anyway, whether it's black or white, and the converse is true for the west wall. So I'm not generally aware of mold problems to be concerned about, but maybe it's worth somebody looking into it.
Another question just came in, which is, have you examined active cooling coatings that have been developed in Purdue?
Yeah, well, okay. So I wouldn't call them active cooling per se. To be diplomatic, I would just say that the performance of the coatings that have been developed at Purdue would yield a cooling benefit that I would estimate to be about 10% better than what you have in available bright white coatings. So you can certainly use it, but I wouldn't expect to see a substantial improvement. It would be a modest improvement.
Another question is, are cool walls certain paint colors, or are they certain substances painted or attached to walls? Or are they a surface treatment?
That is an excellent question. And so let's see if I've got a little picture with the, I'm just going to use this to answer some of those questions. Cool walls could be an exterior wall paint, or it could be a pre-painted cladding or a pre-colored siding. So any kind of wall material that you can think of, there can be a cool version of it. Sometimes a cool wall will just be a light colored wall that's doing a good job of reflecting both visible light and sunlight as a whole. In other cases, it'll be what we call a cool color, which is a pigmented system that is preferentially reflecting the invisible part of sunlight that you can't see, while reflecting visible light in whatever way is needed to get the color that you want. This is the same strategy that's been used for roofs for a long time. So you can get a bright white roof if you don't care about the color, or you can get a cool colored roof if the choice of color is an important consideration. So the same thing would work for walls.
Is there such thing as a warm wall for colder climates, or a negative impact of cool walls in colder climates?
Sure. So when we are evaluating the effect of a cool wall on energy and carbon, we consider the entire year. So I'm not just presenting summer results. If there is a winter heating penalty, that's factored in. But if you are in say a northern climate that is more heating dominated than cooling dominated in its needs, then what we found in our study across the US is that the cool wall is not as effective. So that's why we generally recommend cool walls across California, but for the US as a whole in the southern half. And I suppose you could look at using a deliberately dark and solar absorptive wall in warmer climates. It might not be the best move though, because even a climate that has a cold winter may also have a pretty warm summer. So you might not enjoy the effect in summer quite so much.
Related to the cold climates is, have you looked at reducing emissivity in cold climates?
Actually, there is a study that was just published in Science last month. There's a team of material scientists here at Berkeley Lab and at UC Berkeley that developed TARC, a temperature adaptive radiative coating. And it, based on its temperature, will lower thermal emittance when it gets cold as a way to try to retain heat during the winter. I helped them with some of their energy analysis. So if you do a search for Berkeley Lab and TARC, you can find a nice news release that will talk about a technology that does exactly that.
See, lots of questions coming in. This is related to sticking with cool walls. Has any study been done on the loss of heat gain for the heating load?
Yes. So all the studies that we do, we consider every hour of the year. And we look at not only the reduction in the need for cooling, but the increase in the need for heating. And that's what led to the recommendation to use cool walls in the southern half of the continental US.
Let's see, about switching away from cool walls, can you describe new or retrofit pavement options?
Sure. We've done a lot of work on cool pavements. Pavements are a lot trickier than, say, cool roofs or cool walls, because pavements carry traffic, so they tend to get dirty. I would say that right now, reflective pavement technologies are not as mature as reflective envelope technologies. And I would point anybody who's interested to ongoing work being done both in LA and also by folks at Arizona State University. where they are in fact studying the performance of things like coatings for streets and parking lots. I don't have a strong recommendation yet saying that here is a particular cool pavement strategy that we know will stay reflective and will give you over its life cycle energy savings or carbon savings. It's an ongoing research area. But my guess is that within the next decade, we'll be much further along and we'll have some strong recommendations to make.
Ronen, thank you so much. I don't want to dig in too much into Nihar's time as he's next and starting momentarily, but thank you so much for this really engaging discussion.